All right. Okay. So let's go over the oxidation numbers on here. So which one should we assign first on here? Oxygen. What are we going to give that? -2. Remember, the whole thing has to equal 0. So that's a total of -6. So what's aluminum got to be? +3, or if you're looking down here, 2 aluminum, so +6. A lot of times it's just their ion charge, right? Especially the ionic compounds. Okay, how about here? Which one are we going to assign first? Magnesium. We're going to give that a +2. And then what's iodine got to be then? Yeah, -1. Okay, what's the whole thing got to total up on this one? -2. So what are we going to assign oxygen? -2. So what's sulfur here? +4. Nice. How about copper? What's that going to be? 0. That was easy. Okay. In this one, where are we going to start? Oxygen. What are we going to give it? -2. Okay, now, this is a little tougher here. What should we do next? We could do sulfur next. What's that? In this case, the sulfate won't equal 0. The only time you'd have it equal 0 if it's by itself. Here, you have to kind of use the fact that you know what sulfate's charge as a polyatomic ion is. So you guys remember that? So what's sulfate's charge as a polyatomic ion? -2. So what's copper got to be? +1. So since sulfate anion as a polyatomic ion has a charge of -2, its oxidation numbers end up adding to -2. Yes? It does. We just haven't got there yet.
Oh, okay.
Yep. So what's sulfur got to be then? +6. So these are the tough ones, the ones that transition metals. You have to use the charge of the polyatomic ion to figure it out, and it's going to be just that charge. Does that make sense? Kind of make sense? We'll see another one, so we'll watch it again. Okay, how about Br2? What are we going to have here? 0. It's an element. Okay. This one here, what should we assign first? Calcium. What's that going to be? +2. What's next? Hydrogen. +1. So what's oxygen going to be? -2. Grand total of -4. All right. How about sodium bromide here? +1 for sodium. Yeah. Next. -2 for oxygen. So grand total of -4. So what's +3? So bromine +3. Okay, so this is another one where we've got the polyatomic ion that helps us get the charge of this. So what's Mn's got to have to be here? It'd be 2. Yep, because there's just one of them, so it'll be +2 because nitrate's got a charge of -1. We have 2 nitrates. How about oxygen? -2. So grand total of 12. Collectively, the nitrogen is going to be +10. So what's nitrogen's oxidation number? +5. Are we doing okay on these? Just a few challenging ones here and there, right? So how many people are feeling really good about this right now? Good number. How many people feeling, decent? Okay. All right, a few there. How many people are just like, what is this? This is still super confusing. Okay, so we'll keep on working on that. Keep on working on that. Okay, so this is the first step to what we're doing today. So what I want you guys to grab and direct your attention to is the back side of this sheet. So in the front sheet, you had the rules for assigning oxidation numbers. Now we're going to flip it over, and we're going to do this method of balancing using the half reaction method. So this is the kind of method we use if we're doing any sort of reactions like involved in like rusting or those reactions found in batteries. So it's pretty common stuff. And we're going to go real step by step on these. So when you're doing these, you're going to want to just go in order. If you follow the steps, you're going to always do it right if you follow the steps correctly. The next thing, you're going to do a ton of these, so by the end you'll have these steps memorized. So I'm giving you assigning a whole bunch of them. This is actually the last new thing I'm teaching you for this unit, and it's just going to be practice after this step today. So let's try doing one of these. So let me get a sample problem here. We're going to balance this reaction. So we're going to have tin plus 2 plus Cr2O7. It's a negative 2, that's dichromate. And the other side, Sn plus 4 and chromium plus 3. So we've got a tin dichromate reaction going on here. So, we're just going to go down the steps right now. So we're on step 1. We're going to assign the oxidation numbers to all the species in the reaction. So the nice thing is some of these are just, it's ions, so it's just their charge. So like here, Sn plus 2, that's already the oxidation number, right? Because like all the ions, that's our oxidation number. Where we have to work with it here is chromium in the dichromate. What's the whole thing have to total up to here? Minus 2. Okay, so we'll give oxygen minus 2 for a grand total of negative 14. So what's chromium going to have to be? Yeah, it's going to be plus 6 because we had 2 chromiums equaling plus 12, so plus 6. So that's chromium's oxidation number there. Okay, again here, our other tin, it's an ion, so that's its oxidation number, and our chromium over here, it's an ion, so that's its oxidation number. So we only really had to get one oxidation number right here. Okay, now we're on to step 2. Split the reaction into 2 half reactions based on changes in oxidation numbers. So remember oil rig here. Oxidation is a loss of electrons. Reduction is gain of electrons. So which of these here is being oxidized? Which one is losing electrons? Which element here? Tin. Tin is losing electrons. Yeah, its number is going up. So it's losing electrons, making it more positive because our electrons are negative. So right here, I like to connect a little line, a little ox next to it to indicate this is the oxidation. And then, let's just do a double check here with the chromium. It should be being reduced. Now reduction is a gain in electrons. So it's going from positive 6 to positive 3. So yeah, it's gaining electrons. It's becoming less positive. So that's a reduction. We got our reduction, so our redox here. Okay, so we're still on step 2. Now we need to rewrite these. So that might be kind of like a sub-step. Like we split it up, and we could say, whoops. We could say here, rewrite. That might be helpful. Okay, so now I'm going to rewrite these. And something I always do is I recopy the oxidation numbers from above. So since the other ones are ions, I don't have to recopy anything, but I do want to bring this plus 6 down. Because really what we're just focusing on is the stuff that's being oxidized and reduced. Nothing's really happened to the oxygen here, so we're not going to bother with it. So now we are on step 3 here. So we're on to balance the atoms that are oxidized and reduce. This is a really important step. I would even say circle it, because sometimes people forget to do this, and if you don't do this step, none of the other steps will work. So make sure that you balance. So let's take a look here. Tin, is it balanced? Yeah, there's two tin. There's a tin on the left, tin on the right. You don't have to worry about the oxidation numbers at this point. Yeah, so tin's fine. How about chromium? No, what do we got to do over here? Add a 2. And we're not going to worry about the oxygen, just the stuff that's being oxidized and reduced. So oxygen, we're going to handle that later. So that's step 3. Very important step. Now we're on to step 4. So it says add the total number of electrons lost to the right side of the oxidation half reaction. Add the total number of electrons gained to the left side of the reduction half reaction. And what I want you guys to remember with this step is to add electrons to the most positive side of each half reaction. You might want to write that down. Add electrons to the most positive side of each half reaction. So whichever side is more positive, you're going to add electrons to. Add electrons to the more positive side. Add electrons to the most positive side. Now let's do that. So we're basically balancing charge with electrons. So we got +2 here, +4. What side's more positive? The +4 side. How many electrons do we have to add? 2. Yeah, we're going to add 2 electrons. So now the charges are equal. +2 and essentially +2 on this side as well. So 2 electrons to make this side, these 2 sides equal. Now, let's take a look down below here. What's our total charge on this side? +6. So good. I'm glad you said +6 there. A lot of times people forget to take the coefficients into play. So we got +6 over here, and what we got over here? +12. Because you've got 2 chromiums that are both +6. So how many electrons do we have to add on this side to balance it out? 6 electrons. Something I want you to notice too, the electrons will always be on opposite sides. You're always going to end up with the electrons on one side for the oxidation and the other side for the reduction. It's always going to it's always going to balance each other. Okay, now we're on to step 5. Balance oxygen by adding water where needed. We got any oxygen up here? No, so we leave that alone. Down here, we got 7 oxygen, so how many waters do we have to add to the other side? 7, yeah, 7 waters. So because each water contains 1 oxygen, so we'll put 7H2O. That leads us to step number 6. Balance the hydrogen by adding H+ where needed. Sometimes it can be contained in compounds, you have to watch out for that. So let's see here. Okay, we got no hydrogen up here, nothing to deal with, but down here, 7 hydrogen over here, so, or excuse me, 14 hydrogen over here, miscounting, so we got to add 14 hydrogen on this side. And it's 14 hydrogen ions, so that's like someone was asking, how come you're not just doing 7H2? Because we're adding hydrogen ions here. So it's 14H+ because there's 14 hydrogens over here. Okay, which now is going to take us to step 7. Step 7 states, find the lowest common multiple for electrons in the 2 half reactions. They must multiply the coefficients in each half reaction so the same number of electrons are lost and gained. Basically, right now we're balancing electrons by using the least common multiple. So we got 2 electrons here, 6 electrons here. What do you think we got to do? What's that? Oh, we can't divide. We can only multiply. Multiply by 3. That's a good question there. So yeah, we have to multiply by 3 here. So we're going to make this into 6 electrons. And because we've multiplied this by 3, we have to multiply everything by 3 in the top reaction. And now this leads us to the canceling stage. So basically, we are essentially balanced the electrons to balance the reaction. So now we're on to step 8, cancel electrons, H plus, and H2O where possible. So now that you've got these two numbers matched up, you're just going to go like this with them. They're matched up. We're getting rid of them. And now we look to cancel hydrogens. Okay, I got 14 H plus over here. Do I have any H plus over here? Nope, so that's fine. And then let's check our waters. Any waters over here? Nope. Waters over here? Okay, that's fine. So we can't really cancel any of those at all. All right, and lastly, we are on to step 9. Rewrite the total equation, and it should now be balanced. So now we're going to rewrite that stuff. There's not a particular order you have to write them in. It just has to all be there. And that's it. The last kind of extra step you could say on there. So after step 9, double check it's all balanced. So I got 310, 310, 14 hydrogen, 14 hydrogen, 2 chromium, 2 chromium, and 7 oxygen, 7 oxygen. It's done. So that's a balancing oxidation reduction reaction. Let's do another one. And then I can get you guys going on the homework. Again, at first when you guys do these, go very step by step. Have that sheet out next to you, going step 1, 2, etc., etc. BiO3 -1 plus Mn plus 2, giving us MnO4 -1 plus Bi plus 3. Okay, what's step 1? Assign oxidation numbers, yeah. So let's go ahead and do that. All right, this whole thing has to equal -1. Assign oxygen -2. So what's Bi have to be? Plus 5. Mn, it's already got it. Let's come over here to MnO4. Whole thing has to equal -1. Yeah. So what's our oxidation number for Mn here? What is it? Plus 7, yeah. Plus 7. And then this last Bi, it's already been assigned. It's plus 3. So anytime it's an ion, it's already assigned. Okay, what's step 2? Yeah, we got to split it. We got to split into two half reactions. So which ones are oxidation here? So remember that oxidation is a loss of electrons. Which one is losing electrons? Mn. So Mn's going from +2 to +7. So it's getting more positive. Electrons are negative, so this is our oxidation here. Oxidation is a loss of electrons. And then bismuth here, it's going from +5 down to +3. Reduction is a gain of electrons. It's becoming less positive. It's getting more negative. Electrons are negative. And then let's just rewrite those. Again, I just write the oxidation numbers for the ones that are of interest here, just because the oxygen, the other stuff doesn't really matter at this point. So I'm just writing the oxidation numbers for the ones that we're working with in the reaction. Okay, what's next? Yeah, step 3, balance the atoms are oxidized and reduced. How are we looking? We're looking good. One manganese, one bismuth. That step's already done for us. So step 3 is done. And now, what do we got to do? Yeah, we got to add electrons. So this one here, where do we have to add electrons on the top one? On the right, how many are we going to add? Yeah, so we're going to add 5 electrons over here. How about on the bottom? Yeah, 2 on the left. And again, notice it's always opposite sides. We're going to put those electrons. They're going to be balancing. Balance those electrons out. Okay, on to step 5. Balance oxygen by adding water where needed. So on the top one, what do we got to do? Yeah, add 4 waters to this side. 4 oxygens, 4 oxygens. On the bottom one, add 3 waters. Okay, step 6, balance the hydrogen by adding H+ where needed. Top reaction, where we got to add them? Right side, how many are we going to add? Yeah. So we got 8 hydrogens, and now we'll balance with 8 hydrogens. And on the bottom one, left side 6. Okay, on to step 7. Find the lowest common multiple for electrons. So what's our lowest common multiple for electrons? What number? 10. Yeah, 10. So this one doesn't work out nicely where like one's divisible by the other one. So we gotta make both of these 10. So that means on the top one, what do I have to multiply everything by? 2. So now this is 10 electrons. This becomes 16, 2 MnO4, 2 Mn, and 8 for the water. And at the bottom here, I'm going to multiply everything by 5. So we get this to be 10. This turns into 30. 5 of these. 5 of those, and 15 waters. Yeah, this is where they get kind of messy. And on to step 8, the cancellation step. So first we cancel off the electrons. That's always really easy because those are equal. So electrons are gone. And then let's move on to our H pluses. Now this one we actually can do some cancellation. We got 30 hydrogens here and 16 here. So we can just cross off these 16 and subtract 16 away from this 30. So how many are we going to have here? Yeah, 14. This turns into 14. Okay, so we got hydrogen taken care of. And now water. 8 on the left, 15 on the right. We can get rid of these and be left with, 7 waters. And now, on to step 9, rewrite. That's bad. And again, kind of your step 10, if you will, just do the double check. 2 manganese, 14 hydrogens, 5 bismuth, and then 15 oxygens, 8, and then 7, so 15. And that is how we balance a redox equation. Okay. So again, key thing, have this sheet out, be going step by step by step as you go. Go step by step. All right.